Hey boys and girls, welcome to the Calculus Think Different television. Alright, here we go. Picking up where we left off with the fire drill. Alright, no problem. L'Hôpital's rule, speaking some French. I wish I could. I can only speak Spanish, senor. So what we did first was we had f of x equals 3x squared minus 21x plus dirty, over x squared minus 4. And we plugged in this. We did this right in class. We plugged in 2, and we got 0 to 0. There was a hole. We knew that. We factored, and we got negative 9/4. So that we did that in our notes. And then, you know what? We got a little tired of factoring. You know, I hate factoring. Do we really have to factor every time that there's a hole, that there's a 0, 0 indeterminate answer? I don't know. Well, if there was only a man who speaks French in a funny wig who's here to help us. And yeah, there he is, Mr. L'Hôpital. And so he created this rule right here, which you're writing in our notes. Which this part is where we need to focus on. The limit as x approaches a, and a is some value of, so there's some function and some function on the numerator and denominator. It equals actually the derivative. So the limit, and I have the function on the numerator and denominator, I can actually find the derivative of those two, and it equals the same thing. How can we use that to our advantage? Let's see. Okay, so now we're back here to this. Let's do the same problem. We got, when we did the factoring, we got negative 9/4, right? Okay, let's see if we can get that using L'Hôpital's rule. Check it out. So, look at this right here. Write this in your notes right now. Write it again, okay? So, the limit as x approaches 2. So the first thing we always do is we plug in 3 times 2 squared minus 21 times 2 plus dirty over 2 squared minus 4. And I get, this is 4 times 3 is 12, so 9. No, this is 0 over 0. Yep, got it. Okay. So this is 12 minus 42 is negative 30 plus 30. Okay, yeah, I got it. Got them straight in my head. Got it. Okay, so we have to do something. So normally we'd factor here, but L'Hôpital is right, like, hey, you know what? I'm just going to find the derivative, and we're going to power rule this thing. So find the derivative of the numerator. So there's a function here. That would be 6x minus 21. Whoop! And this is going to be, the derivative of the denominator is 2x. And so L'Hôpital rule said that the derivative of the numerator and the derivative of the denominator equal the same thing as the function when I'm finding the limit. So what does that mean? Well, the limit as x approaches 2 of 6x minus 21 over 2x, let's see what we get. Let's plug in 2 again. Just like after we factored, we're going to plug in that. So that's going to be 6 times 2 minus 21 over 2 times 2. So that's 12 minus 21 is negative 9 over 4. Oh my god, we got the same goddamn thing. Look at that. Amazing. So L'Hôpital was able to get the same answer as factoring. So now, whenever I have 0 over 0, I have two things to do. 1, I can factor, or 2, I can use L'Hôpital's rule. Oh yeah. Awesome. Alright, let's keep practicing. Look at this. Some examples, huh? Write this example in your notes. So this one, oh man, if I get 0 to 0 here, I would not want to factor that thing. That looks crazy. So hopefully L'Hôpital will help us. But I don't know what's going to happen. Let's plug in 1. So the limit as x approaches 1, you can pause the video if you want so you can write this whole thing down in your notes. 1 to the 5th minus 1 to the 4th minus 7 times 1 to the 3rd plus 7 times 1 squared plus 5 times 1 minus 5 over 3 times 1 to the 4th minus 1 to the 3rd minus 2 times 1 squared plus 1 minus 1. I don't need those two equal signs right there. Equals 0 over 0. Wow. Okay, well, what can we do? Well, we can factor this, but I'm not going to do that because that's going to take forever. I don't even know if I know how to do that. But L'Hôpital is here to help us. So the limit as x approaches 1, what is the derivative of the numerator? Oh yeah, 5x to the 4th minus 4x to the 3rd minus 21x squared plus 14x plus 5. Whoop! That's the derivative of the function on the numerator. Derivative of the function on the denominator is 12x to the third minus 3x squared minus 4x plus 1. There you go. Okay, so what am I going to do now? Oh yeah, so I did the derivative of the numerator and denominator. Let's plug in 1. Limit as x approaches 1 of 5 times 1 to the fourth minus 4 times 1 to the third minus 21 times 1 squared plus 14 times 1 plus 5 whoop, equals 12 times 1 to the third minus 3 times 1 squared plus, minus, my bad, minus 4 times 1 plus 1 equals, you got it? You got it? Because I do. Negative 3 over 6, simplified is negative 1/2. Got it. There you go. There we go. No problemo. All right. Let's try another one. Actually, I want you to do it. So pause the video right now. See if you can hang with this one. I want you to do it. It's actually kind of tricky. See if you can keep up with it. Okay? Once you do it, I want you to unpause the video and see how I do it. See if you can get the same thing as me. Okay? Ready, set, pause. Hey, welcome back. All right. No problem. All right. So first thing we do, plug in. Let's do it. Limit as x approaches 2 of 2 to the third minus 12 times 2 plus 16 over 2 to the third minus 4 times 2 squared plus 4 times 2. That's going to be 8 minus 12 times 2 minus 24 plus 16 is 0. This is 8 minus 16 plus 4 times 2 is 8 plus 8 is 0. Got it. 0 over 0. Okay. Two options. 1, factor. 2, use L'Hopital's rule. Let's use L'Hopital's rule, shall we? So the limit as x approaches 2 is 3x squared minus 12 over 3x squared minus 8x plus 4. Okay, so what we do after we do L'Hopital's rule, we plug in, right? 3 times 2 squared minus 12 over 3 times 2 squared minus 8 times 2 plus 4. That's 4, that's times 3. What? Oh my god, we got 0 to 0 again. We continue, got indeterminate. Oh, what are we going to do? Well, we're just going to re-up on L'Hopital's rule. No problem. Limit as x approaches 2. Now I'm going to find the derivative of this, because the derivative of this yielded an indeterminate form. So I'm going to find the derivative of this now. Okay, so that's going to be 6x over 6x minus 8. Okay, let's plug in 2 again. 6 times 2 over 6 times 2 minus 8. And that is 12 over 4, which is 3. Hopefully you got that. Hopefully you got that. Okay? Hopefully you got that. Let's check it out. So, 2 more. 2 more. Okay? You can pause it if you want to and see if you can do them, and then unpause it just to check your answers. I'm going to do these in a second. But remember, L'Hopital's rule only works if I have 0 to 0, a whole indeterminate form. So be very careful. All right. So look at this right here. So let's plug in 0 here. So actually, you can kind of do it in your head, right? Because this is 0. This would be 0. This is 0. This is 0. So all of this doesn't matter. This is 0 also. So 0 is in the denominator if I plug in 0, and I have 3. What does that tell us? That doesn't tell us to use L'Hopital's rule. That tells us that we have a vertical asymptote. Remember that? We have infinite discontinuity at x equals 0. There you go. All right, this one. Do I have to use L'Hopital's rule? Let's see. Hopefully you paused it, and hopefully you did it out. You're going to see if you got the same answer as me. So I'm going to plug in 5 first. 5 to the third minus 125 equals 2 times 5 squared minus 4 times 5 plus 7. This is 0 because 125 minus 125. This is 2550 plus, what I said, equals, yeah, that's 0 also. Good, got it. Okay. So, All right, indeterminate, no problem. So what we're going to do, use L'Hopital's rule. Limit as x approaches 5 of, what's the derivative of my numerator? 3x squared. What's the derivative of my denominator? 4x minus 4. Got it. Okay, so what we're going to do now, plug in 5. 3 times 5 squared over 4 times 5 minus 4 equal 75 over 16. Let's leave it like that. There we go. Done. Okay. So if you want to practice some more, we have this link right here on 17 Calculus, and all of the ones on this link, and it's attached to this website. If you want to practice more, I would do all the ones that are not trigonometry or natural log or anything. Anyone that looks like this, number A02, A03, A04, you click on the solution or the answer, and it gives you what the answer is, so you can practice this if you want to continue to study. Particularly this one. I like this one. All right. Great job. I will see you on Monday.